Interesting, isn't it?
But with these fractal toroidal geometries, well, I mean, you know about Masahiro Daibo's work, I assume, right?
I'm not great necessarily with names unless I've personally met them.
They used zero inductance thing where you have a wire going straight and then you had a wire coiled back around it to the original point, and they were showing that sort of wire, it will kind of like a caduceus coil as well. That sort of wire was able to pick up a voltage, it induced voltage from a change in the magnetic vector potential alone.
Okay.
And so anyway, this is important for these fractal toroidal structures, because what Masahiro Daibo demonstrates is that, okay, you have this magnetic induction term from the magnetic field. You also have an induction term associated with the divergence of the magnetic vector potential, which, or not even just a fluctuation of the magnetic vector potential over time, because of the Aharonov-Bohm effect. The Aharonov-Bohm effect still happens in conductive media, and so it will still cause charge separation and basically diffraction of charge, of the electrons, really, and possibly other matter, but usually when we're talking Aharonov-Bohm, we're talking electron diffraction. But if you have electron diffraction in a conductive medium, and that medium is coiled in a way where all the peaks line up, then you can get induction from just a magnetic vector potential field that's varying in time.
Once it's cohered, an unlimited amount of matter to go into a very small point.
All right, check this out. This experiment is meant to show you induction without it actually being too close to the coils. These are vortex coils. This experiment's going to be done just a little differently than most. So there's our power supply, that 12-volt battery. This is our regular modified joule fief circuit. So this transistor here is going to pulse the primary of this vortex coil. And this transistor is going to pulse the secondary of this vortex coil. We're going to pulse it at 1000 hertz, 3% duty cycle, 20 volts per pulse. This meter goes to the full wave bridge rectifier of that pickup coil, which is 120 wraps of a ferrite core. Now technically we shouldn't get really anything out of it, but let's hit it and see. Alright, turning on the primary, we're pulsing the primary in 3, 2, 1. We have 102 volts on our meter, 1 neon running from our full wave bridge rectifier. Remember, it's not touching, ladies and gentlemen. So let's see if there's an oplosive effect by turning on the secondary in 3, 2, 1. Our secondary is on. We reached 120 volts, and now we're down to 115. And both neons are running, all coming from that 12-volt battery. And it's not even close. All right, ladies and gentlemen, feel free to explain in the comments section, and I hope you all have a really great day.
The Aharonov-Bohm effect. The Aharonov-Bohm effect is a known piece of physics that most people do not know. And the Aharonov-Bohm effect has been calculated in 1998 by Afanasyev and Dubovik at Dubna to occur in the center of these fractal toroidal solitons, these exotic vacuum objects. And so you have both the thing that can cohere matter into a phase singularity spin and cause, once it's cohered, an unlimited amount of matter to go into a very small point.
Hey everybody, this is the Vortex coil inside of a case, and no power going to the circuit except from the function generator at 880 hertz, 20% duty cycle square wave, and I'm just going to turn up the function generator. There's no power going to the transistor other than the function generator. Check this out. Can you see that? Can you see that?
The conversion of vacuum energy into another form, in this case, light, heat, radio waves. So we know of a laboratory that has some experiments going in which they were creating turbulent bubbles in fluids and then measuring the energy in the water by the heat, and they were getting over unity efficiency. And so we have now arranged to have those devices shipped to our laboratory, and we're going to do a very detailed study. But in this case, we're talking about kilowatts.
We're going to change our frequency on our frequency generator to 7.83 hertz. That's an interesting number. I'm sure a lot of you know what that number is. That number is the resonant frequency of Earth. I believe it's the resonant frequency. Don't quote me on that. Nikola Tesla used to use 7.83 hertz for multiple reasons. It was his kind of go-to when it came to resonating with the ground, his Wardenclyffe tower. At least that's the theory. Alright, so what I'm going to show you is I'm going to take this magnet and I'm going to put it standing up in the middle, and I'm going to show you spin, but not just spin. If everything goes right, if it flips the right way, I'm going to show you orbital spin and polarization. Alright, so we're turning it on in 3, 2, 1. Okay. So it flipped to the blue line down. So it's polarized to the point where it ain't going to even move. But if it flips the opposite direction, watch what happens. 3, 2, 1. Orbital flow. Is that not crazy? And I'm not picking up. I have to get close for the magnet to pick it up, or for the pole indicator to pick it up. Now watch this. Okay, now of course, it's got a mind of its own. Don't try this at home, folks.
Extreme multi-axis hydrodynamic shear. And here's the thing. There's only one structure in nature that allows for negentropy, and that is the vortex. That is the vortex. And according to Maxwell, the ether is made up of a lot of vortices.
Well, when you go to look at the numbers, you find out that there's enough energy in the coffee cup to evaporate all the world's oceans if you could get it all of it. So this raised the issue among theorists. Well, can we manipulate this energy? Could we tap it for spaceflight application, for example? And there are a couple ways to go. Could we get propulsion out of it? Could we use it as an energy source? And so these are the areas that modern theorists are looking at.
Let's break it down a little bit more. A stable electron, a stable proton, and a stable neutrino, and their anti-particles. they are stable in our vacuum state. If you are able to change the vacuum state, all of the rules change. A proton is able to be stable for all of time, but if you change the vacuum state, then all bets are off as to what you can do. You rewrite the rule book, and that is what an EVO does. I think the bit that's important to me is, can you take two different de Broglie wavelengths, that's the wave description of a piece of matter, and get them to the same kinetic energy and bring them in phase? And this can do that. And that's the only thing that I'm interested in.
All right, I'll try and do this quick. It's never quick. All right, we're going to pulse it at 1,000 hertz, 1% duty cycle square wave, 20 volts per pulse. We're going to pulse the primary, the secondary, and then we're going to put a little boost on it. We're going to control the boost this time. All right, in 3, 2, 1. Now we got the primary floating, secondary in 3, 2, 1. All right, so we got that balanced. Let's put some power into it. And we can control it as well. We'll bring it up. Or maybe we'll bring it down just a little. Or right back up. See, the wires are kind of making it stick a little, which is an issue for me, but let's see here. All right, everybody. You have a great day.
Hold on to that thought, because I want to go at a different topic on relative neutrinos, but I want to let Michael respond to that after.
No. I need to finish the last part of that argument and we're done.
Okay, because
that's a normal vacuum object, a normal atom maintaining its stability, maintaining its non-radiating boundary, right? Mm-hmm. In an exotic vacuum object, you are literally creating the same kind of structure as an ordinary electron and proton, even an atom, but you're creating it at an exotic state in our vacuum. And for it to survive, it needs to, one, create its non-radiating boundary. Inside that non-radiating boundary, it has to have a different space-time, and it needs to have this little arse where it sucks in ordinary matter from our vacuum state, extracts energy from it to keep it operational, and spits out the balance. And that's how it works, in my view.
That would be much more powerful than fission or fusion. That you could just take.
Oh yes, it's unlimited at any point in the universe.
Any old matter, yeah, or even the relative neutrinos, maybe.
And this is what was written in a CIA released document in 2017. I reconstituted this because they didn't think it was valuable. It was a newspaper article when scientists were defunded en masse in 1992.
Oh, I'd love to see that article.
It was people on the peripheral of the energetics program.
Call it whatever you want to call it, but the beautiful approach of it, which was also something that Puthoff wrote about in 1987, which was the ground state of the hydrogen atom, is that, in my opinion, and I think Bob just said this beautifully, is that you imagine that like all the atoms are breathing energy in and out. That's what keeps them in this equilibrium state. So that's why they're so stable all the time. Otherwise, they shouldn't be stable.
Non-equilibrium steady state. It's a non-equilibrium steady state. It's an important distinction, and we'll get into that in another.
Because they're broken out of
the energy.
Yeah,
we'll talk about that. sorry.
But that's great. And this conversation
is
also
specifically non-equilibrium. Is that not every single thing is exactly the same kinetic energy?
Yeah,
fair. And steady state versus equilibrium is a very nuanced topic, so it's a conversation for another time.